Starting off with lesson 8.1. A lot of this we did talk about last week with the Pythagorean theorem and the radicals. So I'm going to jump straight to that example 1. It tells us to find unknown side lengths of each right triangle. How did we learn last week to find missing sides of a right triangle? Yep, Pythagorean theorem. So that's that a squared plus b squared equals c squared. Now, with this formula, can I just throw in numbers wherever I want? No, order matters, right? Which one matters? That c, right? The hypotenuse. So our biggest side or the one across from that right angle is our c. So we don't necessarily know what c is right now, so I'm just going to put that as x squared equals, and then does it matter the order of the 12 and the 15? Nope, so I'm just going to have this as 12 squared plus 15 squared. So now it just turned it into an algebra problem. What is 12 squared? 144 plus 15 squared? 225 equals that x squared. Biggest thing, don't forget to square all three of those values. What do I do next here? Add these two together. If I add those, I get, I believe, yes, equals x squared. What's my last step here? Take the square root of both sides, so we get x equals 19.21. Cool. Again, I'm not very picky on rounding. Okay. So our hypotenuse length on that one is 19.21. What about c? Do you agree we're still using the Pythagorean theorem? Yes. Okay. What is my c value this time? Yep. Our biggest side is 10, or the one across from that right angle. And then my a and b can be x squared plus 7 squared. So solving here, we have x squared plus 7 squared. 7 squared is 49. 10 squared is 100. How do I solve this here? Subtract 49. What's 100 minus 49? 51. From here, square root both sides. If I take the square root of 51, what do I get? X equals 7.14. All right, let's look at these. Example 2 also, because you know how to do these. Again, on part A, is that any different than what we just did? No, we're finding a missing side length, okay? What is my c value? C or x or whatever variable you're choosing. Okay, so we have x squared equals, and then 9 squared, 40 squared on the other side. What is 9 squared? 81. 40 squared? 600. Yep, equals x squared. If I add those together, I get 1,681 equals x squared. Last thing, take the square root of both sides. We get x equals 41. Okay. And then last example here, it's a little different. It wants to know if this triangle is a right triangle. How do we determine if it is a right triangle? We got to use the Pythagorean theorem still, right? How do I determine what c is? It's the longest side. In this case is 37. So 37 is my c value. And then I have 35 squared plus 12 squared. What is 35 squared?
1225.
Thank you. 1,225. 12 squared? 144. And then 37 squared? 1,369. Cool. What's the last thing I can do here to simplify? Yep, combine here. What does that combine to? Okay, so what does this tell us then? That it is a right triangle because this is a true statement, right? So our answer in this case is yes, it's a right triangle. A follow-up question. What is the right angle? N, O, or M? M. How do you figure? Yep, it's, okay, I heard a couple different reasons here. It's across from that longest side, or the hypotenuse, which is true. Or I also heard it was connected to the two smaller sides. It's also true. Okay. The rule of 8.1 is about special right triangles. Now, there are two different types of special right triangles. I'm only going to focus on one of those today. Okay, so the first one we're going to focus on is the 45, 45, 90 special triangle. So go ahead and draw yourself a right triangle. That looks something like this. Again, what classifies a triangle to be a right triangle? Has that 90-degree angle. Cool. Okay, so do you agree we have that 90-degree angle? Okay, so the 45 is the other two angles. 45, 45, 90. That's where it gets its name from. Okay, the name is from the angle measures. Okay, so a 45, 45, 90 triangle, let's break this up a little bit. We are going to be talking about how we know what the side lengths are. So, thinking of past knowledge that you've learned so far this year, what can you tell me about this triangle?
It's an isosceles.
What do you mean by it's an isosceles triangle?
The two legs are the same and then the hypotenuse is the different one.
Okay, you knew that because these two base angles are the same, right?
Mm-hmm.
So if those two base angles are the same, do you agree we can also assume that their opposite side lengths are the same? Okay, so go ahead and make that mark on there. Since those two angles are both 45, then that means their corresponding sides are congruent to each other. So, in regards to a right triangle, what are the names of these two sides? We know this is the hypotenuse. What do we call the other two sides? Legs. Yep. So make a note to yourself. Legs are congruent. And again, we're specifically talking about that 45, 45, 90 triangle. Okay. So we know the legs are congruent. Right now, I'm just going to represent those legs as x values. Okay, so my x value right now are the legs, just for a representation. Okay, go ahead and mark those as x also. Okay, this diagram is kind of going to serve as your model. Okay, how do we know what the hypotenuse is?
Pythagorean theorem.
We could use Pythagorean theorem. With these special right triangles, these diagrams actually give us a formula to use so that we don't have to use Pythagorean theorem every single time. Okay, and what that formula is to find the hypotenuse, we are going to multiply the leg by the square root of 2. Okay, and the reason that we know that is because that's the theorem. Okay, this is kind of the theorem I'm giving you, or the formula that you can use. Okay, it's just in terms of a diagram this time. Okay, so I'm going to ask you something real quick. If I draw, and you can draw this too if you want, I'm going to draw a little smaller one over here just as an example. Okay, so here's my right triangle, and it's 45, 45, 90. Okay, if we are ever dealing with special right triangles, they will always have the angles labeled for you. Okay, they will always have them labeled for you, or they will tell you specifically what kind of triangle it is. Okay, so if I told you that this side right here was, let's say, 10. What else do I know then?
These are x values.
The other leg is also 10. Okay?
Like that x was 10.
Right. Because what our formula says is to get to the hypotenuse, I'm going to take x times the square root of 2, which is my leg, right? So I'm going to take 10 times the square root of 2. So last week's kind of coming into play here. What happens when I multiply these together? Does it turn into square root of 20? Why not? Right. We cannot combine whole numbers with radicals. They stay separate. So this turns into 10 square root of 2. And that is how I get the length of my hypotenuse. Okay. Yes, we can use Pythagorean theorem here, but this little diagram formula theorem gives us exact values for that. Then you don't have to ask me, what do I have to round it to? Okay, you're going to keep your terms or your answers in terms of radicals. Okay, so I'm going to use that same diagram. We're going to do a bunch of different examples, so don't get worried about writing these down right now. If I had, let's say this side length was 12 square root of 2.
And the legs are 12.
Say, Kate, what'd you say?
The legs are 12.
Yeah, how do I go from the hypotenuse back to the legs?
Just give you the radical legs.
Yes, but it's not always going to be that easy. So here, again, if I said this leg was 10 here, how did I know what to do to get to the hypotenuse? We multiplied, right? Because by the formula, we multiplied. So how would I go back to the leg?
Divide.
I would divide, right? If we're going backwards, I'm going to divide. So with this 12 square root of 2, I'm going to take that and I'm going to divide by the square root of 2 to get back. Here, what happens?
It removes the radicals.
Right, these can cancel out, or again, you can go through the process that we did last week. But if it's ever works out nice like that, these can just cancel out, so I'm left with what? I'm left with just 12. So that gives me my 2 leg values. Okay, what I want you to understand about this, you're never going to use any other number except that square root of 2. Okay, and that's because that's what the formula tells you to do. Okay, I'm getting that square root of 2 from the specific formula that I'm giving you. Okay? So on this example 3, they told us that it is a 45, 45, 90 triangle, and they have the triangle labeled. Okay, so I want to find both missing side lengths. Normally when you're given a problem with the special right triangles, they want you to find all the missing side lengths. Okay, so you're more than likely going to have 2 answers. So here, they give us a leg. Do you agree? We have a leg. So if they give us a leg, what do I automatically know? The other leg is also the same. So if one leg's 7, the other one is 7. Okay, so now to find this missing side over here, how do I go from leg to the hypotenuse? Yep, I'm going to take that leg and I'm going to multiply that by the square root of 2. Again, where did we get that square root of 2 from? The theorem, right? The diagram, okay? So, to multiply here, again, can I get square root of 14 out of this? No, what does this turn into? It kind of just squeezes together. So we get 7 square root of 2. And again, what did that just give us? That gives us the hypotenuse. Okay. B, what do they give us? A leg or a hypotenuse? The hypotenuse. So we're kind of going backwards. How do I go from hypotenuse back to the leg? Yep. And again, where does that square root of 2 come from? This one. The theorem, right? So again, it was the exact same example I just did with you. What happens here?
The 2 cancel out.
Yep, these square roots of 2 cancel out, so I'm just left with 12. What did the 12 just give us? Which one? Both of them, right? This is 12, and this one is also 12. If you were unsure, how could you check if you were right? How could you check to make sure your 12 was correct? I can go multiply by the square root of 2, see if I get that exact same answer. In this case, do we? Yes. Okay. Okay, let's just do some examples here. If I told you that this leg was square root of 5, I want you to find the other 2 sides. So I want you to find side 1 and side 2, given that one of the legs is square root of 5. Okay, again, out of what I have labeled up here, 1 and 2, which one is the easiest to find right now? 1, right? Why? It's the exact same, right? Square root of 5, because we know the legs of 45, 45, 90s are the same. Okay, how can I find side 2? Exactly. I'm going to take my leg, and to get to the hypotenuse, I'm going to take that times the square root of 2. And again, we get that square root of 2 from the theorem, right? So if I multiply those together, what do I get? Square root of 10. Always see if you can simplify. Can I do anything with the square root of 10? Nope. So my answer is just square root of 10 for the hypotenuse. If I give you the hypotenuse is 5. Okay, little refresher from last week. Since I'm going backwards, back to the leg, I want to divide by that square root of 2. Okay. Because if we go from the leg to the hypotenuse, we're multiplying. So if I go backwards, we are dividing. How can I simplify this? Can I just leave my answer as 5 divided by square root of 2? No, because why? Can't have a radical on the bottom. How do I get rid of it? Yep, multiply by whatever that radical is in the bottom. In this case, we have square root of 2. Okay, so if I multiply straight across here, what do I get on the top? 5 times square root of 2? Yep. And then on the bottom, if I multiply across, square root of 4. Okay. Can I simplify the top any farther? No, because I can't do anything with square root of 2. So that's just going to stay 5 square root of 2. And then what is the square root of 4? 2. With division, what should you always check for? Simplify. Can I do anything with a 5 and a 2? No. Can I do this? No. So this is my fully simplified answer, even though it looks a little messy. Okay. What did that just give us? That's what I want us to understand.
The other side's a 2.
It gave us the 2 different legs. Good. Little similar. What if that hypotenuse was 8? What if the hypotenuse was 8? Okay, again, on this one we're given the hypotenuse. So how do I go from hypotenuse back to the leg? I heard divide. What am I dividing by?
Square root of 2.
Yep, divide by square root of 2. What do I need to do from here to simplify?
Times by square root of 2.
Multiply by square root of 2 on the top and the bottom. Multiplying straight across here, what do I get on the top? 8 square root of 2. On the bottom, I get square root of 4. Good. Can I do anything with 8 square root of 2?
No.
Nope. On the bottom, what's the square root of 4? 2. Again, is it square root of 2 or just 2? Just 2. Okay. With division, what do we have to check? Simplify. What can I do with the 8 and the 2? Yep, 8 divided by 2 is 4, and then that square root of 2 stays. Again, this gave me what? It gave me the legs. Yep, one or both? Both. Yep. Try it when the leg is 50. Was this one pretty nice? Why?
Because you just got it times.
Right. They give me a leg. First of all, what's this side?
50.
It's also 50. Okay, how do I go from a leg to the hypotenuse? I'm going to take that leg and multiply by what? Square root of 2. Again, a whole number times a radical, those kind of just push together as one term. So this is going to turn into 50 square root of 2. And again, that gives me the hypotenuse there. Try when the leg is the square root of 6. Okay, which of these do I automatically know? The other leg is square root of 6. Okay, how do I find the hypotenuse here? What am I doing with square root of 2? I'm multiplying that, right? Square root of 6 times the square root of 2. So now we're simplifying here. What do I get when I multiply those together? Square root of 12. Why can I combine these to one radical, but I couldn't combine like 50 and the square root of 2? They're both radicals, so they're kind of like terms, right? Is square root of 12 my answer? No, what do I have to do with that? Simplify. What's a perfect square that goes into 12? 4, and it goes in 3 times. What's the square root of 4? 2, and then I keep the square root of 3. And that is your hypotenuse length there.